Today we're turning live streams into queryable tables, no fragile ETL chains. I'll show how Red Panda's Iceberg topics feed directly into Databricks Unity Catalog so analysts can query fresh data with SQL while it's still streaming. Over the last decade, data lakes sprawled. Teams wanted three things at once: table-like semantics, file-based access, and warehouse-grade governance. That's why open table formats emerged: Iceberg, Delta, Hoodie. By 2024, industry momentum consolidated around Apache Iceberg. Vendors across cloud and analytics stacks added read/write support and REST catalogs. The next ask from organizations: make that lakehouse real-time. That's where Red Panda steps in. Red Panda introduced Iceberg topics, now GA on AWS, Azure, and GCP, including self-managed and BYOC. The idea is simple: every Kafka topic can be lakehoused automatically. As events arrive, Red Panda writes Iceberg metadata and Parquet files to object storage. The same stream appears as a queryable Iceberg table through the catalog. The broker becomes a pipeline, no external ETL to stand up, monitor, or heal. This drives three wins. First, zero ETL. New data lands and is immediately available as a table. Second, cost and simplicity. Leverage cheap object storage, avoid duplicate connectors, and reduce operational complexity. Third, productivity. Configuration-driven setup. No Kafka Connect expertise required. Iceberg topics plug neatly into the Databricks ecosystem. Red Panda writes to an Iceberg REST catalog that Unity Catalog can read. You get Unity-managed Iceberg tables governed alongside the rest of your lakehouse. Analysts can open Databricks SQL and query near real-time data. Engineers can continue streaming and transforming via Red Panda Connect or Spark. Authentication flows through OIDC or client credentials, and everything rides over Open REST APIs. Mapping Kafka data to Iceberg is handled by configuration. A one-to-one mapping, topic equals table, uses Red Panda's schema registry as the source of truth. It supports schemaless key/value, as well as Avro, Protobuf, and JSON. You can auto-discover the latest version, select by schema ID prefix, or pin a specific subject and protobuf message type. Evolution is graceful. When schema evolves, the table keeps up. It's literally a topic property, redpanda.iceberg.mode. For fast queries at scale, Red Panda supports automatic or custom partitioning modeled after Spark's partition by DDL. You can apply Iceberg v2 partition transforms, for example, hour, reading_timestamp, or bucket on an ID. This writes data to object storage in layouts that engines can prune efficiently. Production streams always see bad events, wrong schema, garbage payloads, unsupported formats. Iceberg topics include always-on dead letter tables. Invalid records land there instead of silently disappearing. Teams can inspect and reprocess only the bad rows, then reinsert them into the main table. That closes the loop on data quality. Unity Catalog brings governance, RBAC, lineage, discovery, cost controls, and grants a single view across catalogs. It also provides advanced table optimizations, compaction, liquid clustering for better skipping, column stats backfill, and even predictive optimizations to reduce footprint and speed up queries. Managed Iceberg tables remain fully open, read and write via Databricks Runtime or any Iceberg engine through the REST Catalog API. Red Panda handles the table lifecycle on the streaming side. Unified topic/table CRUD, periodic atomic commits via snapshots, with expiry, exactly once delivery, even after instance or AZ failures, schema mapping, partitioning, and DLQs. It also self-manages Parquet file sizes to avoid metadata bloat. You can set a target ingestion lag, say 1 minute, balancing freshness, resource use, and file size through the property redpanda.iceberg.target.lag.ms. During CPU saturation, Red Panda applies back pressure to producers to guarantee arrival times into Iceberg. In Red Panda Cloud BYOC, enabling Iceberg topics is a few commands. Log in, select the cluster, set Iceberg_enabled equals true, choose Iceberg equals REST, point to the catalog endpoint and warehouse path. The same can be done via REST with a patch call. Secrets for Unity credentials are managed centrally via CLI, UI, or pipelines and stored in cloud secret vaults like AWS Secrets Manager, GCP Secret Manager, or Azure Key Vault. IAM is split. Red Panda writes to storage with its role. Unity reads with a separate, locked-down role scoped to catalog folders. You get 35 plus Prometheus metrics covering data and metadata flow, plus a canary that tracks the catalog connection and data quality metrics for DLQ volume. For connectivity in BYOC/BYOVPC, deploy Redpanda and the REST catalog on peered networks or use private link/PSC endpoints to keep traffic private. Think of it like this. Producers write to Redpanda. Redpanda lays down Parquet and Iceberg metadata and object storage. The REST catalog exposes those tables. Unity Catalog governs them. And any engine, Databricks SQL, Spark, Trino, can read and write through open APIs. Streams become tables on tap. When you choose a catalog, insist on open APIs, advanced table optimizations by default, and interoperability, federation across foreign catalogs like HMS, Glue, Snowflake Horizon, or Iceberg REST. A single, unified view of data prevents silos. That's the stream-to-table path with Redpanda and Databricks. Fewer moving parts, lower cost, and faster insight. What questions do you have about schema evolution, partitioning, or Unity permissions? Drop them below. If this helped, like the video, subscribe, and check the description for starter config and metric checklist.